Great. So I'm going to be talking a little bit about the agent component and some other components. I work here at Convex, but let's get started. If anyone wants, I'll come back to the slides so you can scan them either to go to the docs or to these slides. So this is a little bit of the behind the music on some things that I've been working on. It's these components, and this component system for Convex is kind of like these things that you can drop into your Convex backend. It's kind of like a microservice, but a little bit like microservice on steroids, where they have their own database, their own function execution environment, but you can run those functions within the same transaction as your other database operations, as well as subscribe to their data the same way that you can subscribe in Convex overall. And I'm going to talk a little bit about what Convex is, how it works, because I know there's a lot of people probably not quite sure what we're talking about when you say this. This is me. I work here building a lot of libraries and components on top of Convex to kind of go between the primitive layer that we expose and common user ergonomics. So building tools like migrations and workflow, work pool, these things to manage background tasks. But those are all written on top of Convex. Just kind of using all the primitive is available and kind of showing how to build everything that I build is open source. And yeah, happy to chat about them. There's kind of a good ecosystem and community kind of being built around this. So this is going to be the talk, by the way. It's going to look like that. So we're going to go down, and I'm going to talk a little bit about the mental model for how I think about building these, how I think about AI, and how kind of Convex works. So let's start with just a little bit about Convex. It's a reactive backend as a service. So it has a database, function execution environment, store files, all that. Reactive, what does that mean? So when you write data to the database and you're reading data from the database somewhere else, it'll automatically keep that in sync. So the UI will constantly update with the changes that have been made, even if that change is being made by another user somewhere else or from some asynchronous process. So that's the kind of sync that happens that makes it reactive. And TypeScript, what's so great about TypeScript? Well, you get to use it to define your schema, and you write your functions in it, and your client's using it. So the types are truly end-to-end, and there's runtime validation that we have as well. So all of your functions have validators by default that are in TypeScript, produce all the right types, and produce the runtime validation. And the database schema that you write in TypeScript provides kind of runtime schema validation. And that's not just schema validation on reads and writes. That's when you make a schema change, it will enforce that everything in your database conforms to the new schema atomically when you change the code. So a lot of strong guarantees, really cool platform. It's what's enabled me to build a lot of these components really quickly and without having to worry about a lot of the race conditions that you normally have to. Mutations, write data, queries, just read data, actions, which I'm going to talk about in a second, are talk to the outside world, have side effects, hit the, web, run node stuff. And they're the kind of non-transactional world that you have to kind of, the messiness of IO and all that. So, and that is kind of, so there's async functions. And to do that, I'm going to talk a little bit about, what is the shape of AI? How does that look in Convex? How do you map that kind of model of how you reason about the world onto Convex? And so one way that might look is you have a mutation that writes the prompt into the database, and then you kick off an asynchronous action that calls an LLM. Eventually that writes the response back to the database. So after this client called this mutation and it wrote it to the database, this could return to the client, and the client doesn't need to know anything else. This runs asynchronously, and because the client is listing the messages, when that first prompt came in, they got it back via the query. And when the last response gets written in, they get it back via the query. And you can imagine along the way, it could be writing progress, it could be writing failure state, it could be doing whatever, and all that just flows through. So it's about building this data flow model more than it's about, do this, and if there's an error there, then we need to do this. Oh, and the client went away. Oh, they refreshed the page. What are we going to do? Oh, we should check, and then we should pull, and all that kind of just like falls away. So we're not here to talk about AI. We're here to talk about agents, which are so cool. So what does the agent kind of look like in this sphere? So you have a similar, you can write a prompt, you can list messages, and this is just an example. Obviously, with your creative brains, you could make more complex things, but what is the kind of like asynchronous thing that's going on? It might be calling an LLM, calling tools, it might run code, it might branch out to other threads, it might do all these fun things. But along the way, it's kind of reading and writing messages from the database, right? And so when I was thinking about like, okay, what is interesting or what is like annoying about doing this is often like this kind of iteration of like, how do I, or not even how do I, but do I have to really like write all these messages, fetch them out, search them, keep the context window good? Like how, what happens when there's failure? How can I like persist state and like continue it later? How can I kind of pause here, do a bunch of side work, and then rejoin it? And how essentially do I do the state management behind agentic workflows? So that was like some of the thinking that led to the agent component. And so now I want to talk a little bit about this agent component and the associated data model. There's this there's docs with a fun little video, and you write code and you define agents. You can create threads, you can send messages. Here you can like continue a thread and send more. This is all very kind of simplified, but for the sake of just kind of high level understanding, I think the like interesting thing here is even if you're not using Convex, like I think the thing that I hope you like take away is just like by hearing me talk about like how I've been thinking about it and how it kind of like maps onto the world, it like might relate to like how you think about like kind of organizing the problem, because I think agents in some ways about organizing this messiness. It's like we have all these abstractions that we put around things in order to reason about them, and it's not because they're a new different thing, it's because we have a box that we can now call it something, right? It's like microservices, or it's SaaS, or it's this or that. It's like, oh, I pulled in this library, I pulled in this thing, and it's like, how do you compose these things together in order to solve problems? And now we're putting this box that we call agent around something that kind of spins and thinks and has state and then can call out to other things. And there are these units in clouds that can kind of interact. So the box that I'm kind of putting around some of these things, the thread, I feel like is the kind of one of these primitives. So it's essentially like a linear chain of calls to LLMs where you're providing context, you're getting things back, you're saving tool calls, you're saving tool responses. It's very much like the sort of flow, the model that you'd use with the AI SDK, that you would use with OpenAI, things like that. So you can have human agent threads, you can have a single agent that's kind of spinning and doing a chain of thought, maybe with multiple prompting, different models, things like that. You can have two agents collaborating on a thread. You store tool calls and results. You can create them, continue them, make subthreads, multi-user where there's a chat room where everyone's going in and the agents are responding, or you can have a single user. It's kind of designed to be flexible and very simple. It's like, making things easy, but ideally also like really making things simple. Messages, kind of what you'd expect. There's system, there's users, there's the assistant messages where some of those are user visible. Maybe some of those are tool calls. There's tool responses, things like that. And these kind of store the full metadata. So all you need to do is kind of like save in the data that you want to use to prompt, and it will save out like the full kind of like message metadata that you would use to then call any LLM. But cool thing is that like when you do this generate text call on a thread agent, it's like, it will save the prompt for you. It will run the LLM. It will kind of track status. You can also have it be saving the streaming data as it goes along, and it will also store the result for you. And that's all configurable. You can set different context options. It will also, when you generate text, fetch context for you automatically. You can specify, hey, fetch this many recent messages. Also do a text and vector search for the message on the message history within this thread, within all of the user's threads. And that will just kind of like automatically insert it. And while it's also like really convenient to do that, it also gives you the full flexibility to specify what's in my context, what is going into the prompt of essentially, and then what gets saved out. maybe you just generate it yourself and then save it manually. But by doing this, it's kind of doing all the steps for you in a way that allows you to focus on the use case. So messages, to get back to it, they're searchable. They have all the metadata. This is on the client side. You can use this use thread messages, which kind of just, you can look at the code. It just kind of simplifies a lot of the ways that it fetches messages and makes it especially easy to stream messages in as well. So if you're generating streaming messages asynchronously, right, like somewhere else, all the users subscribed to it can see kind of character by character, if you want, like messages streaming in. And it's doing some smart things about batching and grabbing deltas and kind of smoothing the text on the client side so that, it's not like really bandwidth intensive. But essentially the mental model is kind of that unidirectional data flow that we talked about. The last little box is the agent. So those are kind of the things that we often kind of gravitate towards. But they're kind of just this collection of configuration. They have a name, they have what the prompt they are, what model they use, what tools are available to them. And the context, maybe you say, hey, this one's going to grab 50 recent messages. Oh, this one's really just going to search for any related things. This one maybe is going to do some RAG over here with some other files. And they also are kind of a good unit for attribution. You say, hey, I have this huge bill. Which agent is causing me to lose all my money? Is it because I'm spinning over here, or is it because this one user is abusing the system? And so there's some things in there, just some ergonomics around being able to track and associate kind of usage with users, with agents, things like that. So a little bit about the now that's what it is, but it's why is it that way? And so one of the principles here is that kind of code in my mind is king. So you have all these great systems and you want to have it be really easy, and you kind of just plug and play with your cool, cloud integration, businessy thing. And then it's okay, but actually at every touch point in these kind of agentic flows, it's touching code. And code is kind of the most powerful piece that we have amongst all these things. You can set up automatic tool calling, but the most powerful version of that is you call an LLM, you interpret the response, you decide what functions to call, which are kind of what tools are. Those might call out to other systems. And then when you get it back, you call the LLM again, and you can decide to call it with it as a tool call, tool response. But ultimately, code is the thing that you want to be empowered to have. So being code first, putting it in your hands to kind of build things with abstractions and functions rather than kind of listing some sort of domain specific language to define what your workflow should be. So there's also another principle is composition over inheritance. So that might be a term that's familiar to you, but it's instead of at a bunch of touch points, there was a lot of users asking for a bunch of different features. And it's usage tracking, rate limiting, right? I want to do RAG over files that are not part of the message history. And it's yeah. And then, but the thing that I've been trying to do over and over is be does this have to be inside of this component? Or can I build something that is standalone useful that integrates well with it? So there's this kind of can I decompose this into more modular pieces that you can use independently? So I made a RAG component that makes it really easy to drop in files, associate them with namespaces and filters, and define chunking, or it'll do default chunking for you. It can do, really cool combinations of fetching context, combining context, ensuring that if you fetch context from a bunch of different documents, it all linearizes it in the order in which it came in the document, and adds some nice formatting so that LLMs understand this was this, and then there's a little bit of an ellipses. It's that's not contiguous. So just basic ergonomics, things that you would want to build yourself, but might be just that's too low on my priority list, right? And then there's things like rate limiting, where you might be oh, I want to have all these rate limits around how fast people can send messages. What sort of token usage do I allocate for free users versus pro users? And by defining that in code and using the rate limiting component that I've built, you can kind of do all of those checks without having to be in kind of configuration hell of trying to stuff all that into the agent component itself. So trying to pull it out. There's a really cool durable workflow component that allows you to build these durable functions that can be if they crash and they're midway, they will restart and they'll pick up from where they left off. They will journal their responses. They can pause indefinitely and then be resumed years later, midway through the function. And it's like really, really cool, stuff that just allows you to build more reliable kind of like things. And, this is a pretty linear example, but you can have if statements in there. You can have for loops. You can do all these things with code that you'd typically be trying to do, with other systems with some sort of syntax that lets you chain and lets you do this, that, and the other. And that syntax is always just trying to converge on what code is. So like, why not let it be code? And the last, thing is like iterating and investigating is really important. So we built a playground where you can look at the users, their threads, look at their messages. You can look at the details of the messages as well as dig into tool calls and tool responses and see what actually happened. You can play around with context options to be like, what messages did it see that led to that result? Oh, what would it look like if I changed that a little bit? And you can tweak and iterate on those, and you can send messages ephemerally or save them into the history. So you can just be, kind of like getting through that process really quickly. I don't have a final takeaway. I just realized I've just ended. But what will I say? It's great. You should use it, and I'd love to talk to you about like whether this matches your model of what you're trying to build, and like what the missing pieces are, what the missing abstraction pieces are that you're looking around. And you're like, I wish there's something that just made this easier, because that's what I like to do. I'm very motivated by people. Sounds weird, but yeah. Any questions?
First, give it up for Ian. Now, if we got any questions in the back, you can go to the microphone in the back.
Yeah, we're
Streaming.
Yeah, we're streaming it. So if you don't mind, otherwise I can repeat the question.
Thank you.
I haven't read the docs about workflow, but then can you define the time, like how Injects define it? So like repeat it after 3 days, or like retry it?
Yeah. Currently, you can be like, hey, run this thing after 3 days, run this next step, in a year. And yeah, there's also like going to be putting out a feature where you can just kind of arbitrarily pause and then asynchronously resume, so that it's not just time-based, but it could be event-based and all that. Right now, you just kind of end one workflow and start another, but you can do a run after 2 months, and it's pretty wild. Anyways, any other questions? One coming up.
Last question. Thanks.
Hi, I'm curious if I'm already bought into like a bunch of systems that I've put into place for agents that I'm already running. Let's say whether it be like observability or just debugging capabilities that I've built in. Is this use? I know you talked about composition, but do I need to compose these things all together to get the same tool set out? So for example, if I want the message logs to be in like Logtail or something, is there a way for me to progressively enhance my workflow with what you've built?
Yeah. The questions around like, is this all or nothing? What's the workflow to kind of like get into some benefits without throwing everything you have out? And yeah, totally. There's all the components that I mentioned, other than the agent one, are all super usable without using the agent component. And the agent component can also be used pretty headless or pretty, gutless. I don't know how you want to say it, but you can be saving messages, you can be streaming messages, you can be doing things within that and reading the metadata out. And often people will store other metadata in their own tables, and they'll kind of like have their own system alongside of it. And then there's hooks for like getting all of the messages sent and received and getting all of the metadata out if you want to be kind of like sending that out. So people have been using langfuse and stuff like that to kind of get their things. But it's all convex, and then you can kick out to other systems if you want.
All right, one more. Yeah.
Okay. I'll make it fast.
In my current project, I'm already using the AI NPM package coming from Vercel.
Yeah.
And we're kind of doing one-shot prompting towards that one right now. We're getting into actually providing context. And I'm just curious, do we migrate? What would be your suggestion on how we kind of go about that?
Yeah.
And have those two maybe work in parallel?
Totally. Yeah. The syntax is all AI SDK compliant, or like it's the same parameters passed through. So generate text, you just do agent.generate text. It's all the same. Yeah, there's some examples in the docs about kind of like different workflows. But you can also, yeah, you can just decide here, I'm going to do one shot here. I'm going to have a history that I want a user to see. And so you could also just have like one thread per shot, you know, it's all just tiny little database entries.
That sounds good. Thanks.
Cool. All
Awesome.
right, thank you.
Thanks for the question. Thanks, Ian.